Chapter 1, Section 2, Exponents and Radicals, Day 1. We're going to talk about the laws of exponents and zero and negative exponents, and continue with the radicals part of that in Day 2. So a couple just things that you might want to jot into your notes. We know that when we have exponents, the number that the base is raised to is the exponent, and then we have our base. One thing that I just wanted to point out, because this is just a common mistake year after year, notice the difference between the quantity of -3 squared equaling a positive number. Without the parentheses, this is read as the opposite of 3 squared, which notice that the opposite of 9 is -9. So a difference between how you read and how you write something like that, but a very common mistake that I see with students every year. The zero and negative exponents, we know that anything to the 0 power is equal to 1, and we talked a little bit about this in section 1.1 when we talked about the inverses. Anytime we take something to a negative exponent, we can rewrite that so that our exponent becomes positive. A to the negative n is the same as 1 over a to the positive n. So we're going to work quite a bit with negative exponents in this very first section. And 5 laws of exponents that I think you should jot down into your notes. And you'll hear me refer to these just about every time as the way that I'm going to refer to them here. When we multiply monomials, remember a monomial is a polynomial with one term. So when we multiply monomials of like bases, notice that we add our exponents. So a to the m times a to the n is really a to the m plus n. When we have a power of a power, notice that we are going to multiply those exponents together. When we have a product of a power, so in other words we have more than one term inside the parentheses, notice that we have to take each of those terms to that nth power. When we are dividing, notice that we have to take each term in the numerator and each term in the denominator to that nth power. Common mistake there is a lot of kids will do the numerator but forget to take the denominator to that nth power, so be careful of that. And the last one is when we divide monomials of like bases, notice that we are going to subtract our exponents. So you're going to see that these two look an awful lot the same. The only difference is, notice that here my bigger exponent is on top, so when I subtract 5 minus 3, I get a positive 2 as an exponent. Here my bigger exponent is on the bottom, so you can either go ahead and take 3 minus 5, which will give you a -2, so we know 2 to the -2 is the same as 1 over 2 to the positive 2. Or a lot of times I'll just say, okay, if I only have 3 of these 2's on top but I have 5 of these 2's on the bottom, these 3 2's are going to cancel, leaving me just 1 over however many I have left then on the bottom. So you can work that one of two different ways. Go ahead and work with the negative exponents, or just go ahead and always subtract the smaller number from the larger number. And now we're going to get into a couple of examples for you to jot down into your notes on using and applying the laws of exponents. The first two examples, again using the laws of exponents. So here I want to make sure that I multiply my coefficients together. So 3 times 4 is 12. And we talked about our very first law of exponents. When we multiply monomials of like bases, I'm going to add those exponents together. And if it doesn't have an exponent, we can always write anything to the first power without changing the value of that. So I have x to the third times x to the first, which gives me x to the fourth. And my last one, when I multiply these monomials of like bases, I'm going to add those exponents together. So y to the 4 plus 5 gives me y to the 9th. The second one is a product of a power, so I have to take every term inside the parentheses to the 4th power. So I'm going to rewrite this as 2 to the 4th a squared to the fourth, b cubed to the fourth, and c to the fourth. And then of course we need to simplify. So 2 to the fourth is 16. When we have powers of powers, we're going to multiply those exponents together. So that gives me a to the 8th. Powers of powers, we multiply those exponents, is going to give me b to the 12th and c to the 4th. A couple more examples. On this one, again, we have a product of a power, so I need to take everything inside the parenthesis to that second power. Don't forget your denominator. So again, this is going to be 2 to the second r cubed to the second over s to the second. And same thing here, take both numerator and denominator to the third power, so that's going to give me s to the third over r cubed to the third. And then we want to make sure we simplify that. So we have 2 squared is 4, r to the powers of powers we multiply. Simplify over here. Powers of powers we multiply. And now when we're dividing monomials of like bases, remember this is where we're going to subtract our exponents. Okay, so I'm going to go ahead and leave the 4 since that's the only coefficient. R to the 6th divided by R to the 9th means these 6 R's are going to cancel with these 9 R's, but because I have to subtract, it really means I have 3 of those R's left on the bottom. And I have s cubed divided by s squared, so again these 2 s's are going to cancel with these 3 s's, which means I have 3 minus 2, or s to the first, left on top. And our first introduction to negative exponents. And again, all I'm going to do is, since I have a product of a power, I'm going to go ahead and take each of those exponents multiplied with the outside exponent. So I have u to the negative 2 to the negative 3, and I have v cubed to the negative 3. When I have powers of powers, I'm going to multiply them. So that gives me u to the negative times negative is a positive. V to the positive times negative is a negative. And we never want to leave our answer with negative exponents, so we can go ahead and rewrite that as u to the 6th. And whenever I have a negative exponent on top, remember from the last video, v to the negative 9 is really the same as 1 over v to the positive 9. So I'm going to go ahead and rewrite that as u to the 6th over v to the 9th. And now I have a simplified answer without using negative exponents as a part of that final answer. Okay, another theorem for you to jot down in your notes before I show you the last 2 examples. And again, just the theorem on negative exponents, and we've talked a little bit about this in the first video and half of this video. If I have a negative exponent on top, the way to make that positive is to put it on the bottom. So a to the negative m is really the same as 1 over a to the positive m. And if I have a negative exponent on the bottom, the way to make that positive is to go ahead and put it on top. So 1 over b to the negative n is the same as b to the n over 1. Notice when I have a quantity to a negative exponent, I simply just flip the quantity inside. So a to the negative n over b to the negative n is really b over a to the positive n. So notice I just flip that quantity inside the parentheses, and now I have that taken to a positive exponent. So let's see how that works with these last 2 examples. So what I like to do when I have a numerator and a denominator with negative exponents is I like to just make the switch. So in other words, this y to the negative 5, I know to make it positive I need to put it on the bottom, and this x to the negative 1, I know to make that positive I need to put it up on top. So I'm going to go ahead and do that first, and then it's just really going back to the laws of exponents and helping me to simplify those. So I have 8. I'm just going to leave my 8/4 to start with. My positive exponents are okay where they're at, so I'm going to bring up this x to the negative 1. That becomes x to the positive 1. And on the bottom, I'm going to leave my y squared because it's already a positive exponent, and I'm bringing down the y to the negative 5 so I can make that a positive exponent as well. And now it's just a simple simplification. So I know 8 divided by 4 is the same as 2 over 1. When I multiply monomials of like bases, I'm going to add those exponents. And same thing down here, when I multiply those monomials of like bases, I'm going to add those exponents. So we could just simplify that one last time without putting the 1 in my denominator. Not that that makes it incorrect, but just maybe a better way to write your final answer. And the last one, again, we talked about when we have a quantity to a negative exponent, if you flip what's inside the parentheses, all of a sudden now we have changed that negative exponent to a positive exponent. So we can rewrite that as 2v over u squared all to the third power. When we have a product of a power, we're going to take everything inside the parentheses to that power. So we have 2 to the third, v to the third, all over u squared to the third. And one last simplification. 2 to the third is 8